Professor Gardback here with part 2 of the Unit 3 review. I'm going to do a few more problems for you. So this type of problem says, does negative 8 solve the equation? Well, we simply have to put in negative 8 in for x and see if that balances. It's going to be pretty close. It's going to be minus 80. Does that equal 8? And negative 8 cubed is negative 512. Plus 57, and well, we can see this one's going to end in 8, and it's going to be a 0, so probably not, because this ends in a 7. It's going to be really close, but multiply it out in your calculator and prove it to yourself. You get negative 4048. Then you multiply this one by negative 8 and then add 57, you'll get negative 4039. So that is really, really close, but you'll have your calculator available, so it's not equal, so it's no. Negative 8 is not a solution to that equation. Moving on, this asks us to find the quotient of this polynomial here, and if it goes in evenly, that's great. If not, then we'll have a remainder. So we'll have, this is long division, 2x to the third minus x into, and then we'll have 6x to the fifth plus 2x to the fourth minus 15x to the third minus x squared plus 6x. And so we divide that guy in there, and then I'll go in, what, 3x squared times. Multiply that down, and we're going to get 6x to the fifth minus 3x to the third. Notice you put that in the correct column. And you're going to get 2x to the fourth. And we're going to have negative 15 minus negative 3, so it's going to be negative 12x to the third. Then we try to divide again. And can we divide negative 2x to the third into 2x to the fourth? Yes, it's going to be positive x times. And so we multiply that, we're going to get 2x to the fourth minus x squared. We subtract that down. We're going to get negative 12x to the third. Negative 12x to the third, and then 0 plus 0, so that's going to be, this is going to be 0, and I can bring down 6x. Now I have to divide 2x to the third into negative 12x to the third, and that's going to go in negative 6 times. Okay? So it's going to be negative 6. I do that, I'm going to get negative 12x to the third. Yes, plus 6x, and that's exactly 0. So therefore we have no remainder, and our quotient is simply going to be 3x squared plus x minus 6. Check. No remainder. If we did have a remainder, we'd put whatever we got after that over 2x to the third minus x, if there was something left over. But there isn't. So this one's asking us for the equation of the vertical asymptote. So we have to try to factor this out, and just to play devil's advocate, I'm going to assume maybe it's probably 10x minus 1 because 10x plus 1, because 10x does go into 40x, so I'm going to try that out before I can evaluate that. So I'm gonna assume 10x minus 1 might go in, just because that's the same thing here, but with a times negative 1. We always want to deal with a positive coefficient 10x, but if I change this to 10x, it has to change that to negative 1. So we're going to try 10x minus 1 and see if that works. Now on the bottom we know it's going to be negative times the quantity of 10x minus 1. Right, because that's negative 10x plus 1, which gives us back to the original. I'm just assuming it might work. So let's try 4x to make 40x, and then to get minus 1, it's got to be a plus 1 and a minus 1. So let's see, 40x squared plus 10x minus 6x, which gives us plus 6x. That works, minus 1. So now, when we can divide this out, we see we can, because these are the same terms with a minus sign here. So that means that the equation I've left with is negative times the quantity of 4x plus 1, which is going to be negative 4x minus 1. And that we have no horizontal asymptote because the numerator has a higher degree than the denominator, so therefore there's no horizontal asymptote. There is no vertical asymptote. It's none. No vertical asymptote for that one. No horizontal asymptote for that one. No vertical because the denominator is a 1 now. So the only thing we have left is an oblique asymptote when the numerator has a degree higher than 1 higher than the denominator. And our answer is going to be right here. So it's going to be y equals negative 4x minus 1. So after we did all that work with dividing it out, well, that's precisely what you do in order to find the oblique asymptote equation. So there you go. I hope you're able to follow that okay. Now, this one's going to be a piece of work, so work with me here. All right, so they gave us all this information, and they gave us 2 roots and 2 zeros, and they want us to, and the y-intercept has to be 0, negative 40. So we have to come up with a polynomial and work backwards to find out a polynomial that satisfies all these conditions. Well, we know that 2 plus I is one answer, so therefore 2 minus I must be the other, because imaginary answers always come in pairs. So we know we're going to have x minus 2 plus I. Okay, so we're going to have x minus 2 plus I, and we'll have x minus 2 plus I times, I'll get this up here for you so you can see it, times x minus 2 plus I, and then x minus 2 minus I, because remember, these always come in pairs, so it's either 2 plus I or 2 minus I. So it's going to be x minus in both cases, and then the roots go here as an x minus whatever the root is. Okay, so we have that, we have to multiply this guy out, so it's going to be x minus 2 minus I times x minus 2 plus I. Okay, and then we multiply that out. So we're going to x squared minus 2x, okay, plus ix. Now we do the minus, distribute the negative 2, and we're going to get negative 2x plus 4 minus 2I. Now we distribute the negative I, and we're going to get negative ix plus 2I, and then minus I squared. Now we look for anything we could simplify, and we have minus ix and plus ix. We have plus 2I and minus 2I. And then what do we have left? We have x squared. We can combine these two x's. We get x squared minus 4x. And then we have also this, which is minus negative 1, which is plus 1. So that's going to be plus 1 and plus 4. It's going to be plus 5. So now we're going to have x squared plus 5. X squared minus 4x plus 5. And remember, they gave us the first root of a negative 2. So that means I multiply this times x minus 2. And we're going to get x to the third minus 4x squared plus 5x. Now I multiply the negative 2, distribute the negative 2, minus 2x squared plus 8x and minus 10. And I simplify any terms I can, so I have x to the third, and then I have minus 6x squared, okay, and to get there, that one, the combined, it's going to be, was that plus 5x? Yep. So I think that was this was a minus 5x, I believe. It was 4x squared plus 5, and this is minus 5. Where did I get that from? X to the third plus 5x. Okay. Hold that thought real quick. Okay, I just want to clarify one mistake here. The root was x minus 2, so when I get x squared minus 4x plus 5, I need to multiply times x plus 2, not x minus 2. I had minus 2 down here, so it's going to throw everything off. So I'm sorry about that. So we'll continue from there. Okay? So everything was right up to that point. So when we got there, it's going to be x to the third plus 2x squared minus 4x squared minus 8x and plus 5x plus 10. And then when you simplify, you're going to get x to the third, and you get something different. One second. Alright, we were fine here. Just double checking myself. So it's x to the third minus 2x squared minus 3x plus 10. And that's what we get. So I'll bring it down here. So I'm going to get x to the third minus 2x squared minus 3x plus 10. But then when we put a 0 in, we're trying to get a y-intercept of 0, negative 40. when I put a 0 in there, we're going to get 10. And so the way you write that is, so you get a 0. So right now, we have 0 equals, and this factors out. So we're trying to get negative 40. So negative 40 is going to equal 10 times some factor a. Okay? That's what we're trying to find out. So a has got to equal negative 4. So our factor's got to be negative 4. That's what we multiply in front. So therefore, when I get this right here, I have to multiply that through by a negative 4. So my final answer is going to be negative 4x to the third plus 8x squared plus 12x minus 40. And that is our final answer. So that's the polynomial, okay, who has those three zeros, negative 2, 2 plus I, and 2 minus I, and it has a y-intercept of 0 minus 40. If you put in 0, you'll see you get negative 40 right there. So we're good. Check. All right, so study up on these problems and ask questions during the review tomorrow, or today, because you're probably not going to see this now.